Welcome back, as we now begin to describe the various procedures involved in performing a vapour charge. Let us first describe some basic but important preparation tasks. Very important is the selection of the correct type of refrigerant. Somewhere on a unit, this information must be displayed. In our example, we require R22. Serious damage to the system could result if we use the wrong refrigerant. Next, we obtain a service cylinder of refrigerant. It is recommended that the cylinder be weighed to ensure that it has sufficient refrigerant mass for a charge. Using the total mass figure, we can determine by re-weighing after charging how much refrigerant was used to charge our system. The common hose is next connected to the service cylinder, but we must first purge the air out of the line. To do this, make sure that both compressor service valves are back-seated. And that both manifold valves are closed. Next, open the service cylinder valve, then crack open the low side hand control. At the gauge port, slacken the hose connector and permit an escape of vapour for no more than 2 seconds. Air is driven out of the hose by the refrigerant vapour. We are now ready to begin introducing vapour into the system. However, we must first discuss an important point. Our demonstration model has been assembled on site, and we have no accurate data concerning the mass or volume of refrigerant required to achieve an optimum charge. It is for this reason that we need to explain what is to be achieved and how we intend to assess this. There are 3 elements involved in monitoring and assessing a charge, namely pressure, temperature, and compressor load. Let's look at each in turn. Simply reading the gauges on the manifold assesses pressure. A stabilized system will operate with a steady suction pressure and a steady discharge pressure. The actual figures achieved will depend on many variables, such as type of refrigerant, ambient temperature, type and size of the expansion device, size of compressor, and other factors. We can only give you typical information for this type of plant. The sort of pressures you might expect from a cold room unit operating on R22 refrigerant would be in the region of 400 kPa on the suction side and around 1750 kPa on the discharge. Temperature readings can provide valuable information, but you will require an accurate thermometer. The preferred type is a 2-scale electronic thermometer using Type K thermocouple sensor leads. No other type is suitable. During the charging procedure, the most useful temperature data is obtained at the condenser. Where the condenser coil's return loops are exposed, as in our unit, is the ideal location for surface temperature measuring. In a typical air-cooled condenser, there are 3 distinct zones of temperature. The first zone is the top coil, where hot vapour arrives from the compressor. Typically, the temperature drop from the intake position to the first bend in the coil could be as much as 15 degrees. This is known as de-superheating. Further vapour cooling normally occurs in the condensing zone, which is generally in the middle section of the coil. Temperature readings tend to remain constant at several elbows within the condensing zone. A typical drop in temperature would be around 10 to 12 degrees in the condensing zone. The third zone, usually the lowest coil, is the liquid zone. The temperature in the liquid zone would typically be 2 or 3 degrees lower than the condensing zone. This temperature differential is known as subcooling. On air-cooled units, it is fairly simple to take temperature measurements. The two-probe thermometer is recommended. The probes should be made to contact the metal tubes firmly and be insulated, as in our demonstration, using a proprietary plastic adhesive. A comparison temperature is made between the liquid zone and the condensing zone. As a guide only, a correctly charged system would have around 2 or 3 degrees of subcooling. Excessive subcooling is an indication of an overcharge. A further aid to assess a charge condition is your ammeter. As our unit is single phase, we simply check the amperage over the compressor motor's live connection. The maximum operating amp rating will be given on the compressor nameplate. Under full load, a typical refrigeration or air-cooled unit will be operating close to its maximum rated amperage. To summarize, the 3 important elements to consider when performing a vapor charge are pressure of suction and discharge, subcooling at the condenser, and compressor motor load. After the break, we'll work through the charge procedure.